Hey guys, so my name is Shangur and in this video I'll make you understand about segment trees.
Subscribe to the channel, press the bell icon so you never miss an update in future.
Where do we need segment trees? So suppose you are given an array and now you are asked to put a query over the range in this array, okay? Suppose you are asked to find the maximum in the range say 1 to 4, okay? So what you will do, basically the first idea comes to my mind, that's brute force, that take this in some variable and compare every single time, and if that number is greater than the number present in this, then store that. This is clearly of order of n, because in worst case it may ask from 0 to the last index, so it will be of order of n, okay? But when it will reach to a greater extent, then always performing the operation of order of n is a bit complex, and might we could reduce this complexity. So here's when segment trees comes into account. So basically segment tree do what? That reduces this complexity to this. Yes, just this. Now suppose I start with the words. Segment means the parts of this array, okay? And tree means something like this. Now, suppose this is broken into two segments, two half, okay? So 0 to 2 is first segment and 3 to 4 is second segment, okay? Two half segments are like this. So that maximum of these is just 30, okay? And maximum of these two is just 56. Okay, and here it is. And now 30 is again like a segment, so it will again broken into half, so just 10 out of 9 and 10, and here it's just 30. Here it's minus 9 and it's 56. So this is basically a tree that's composed of segments when operated, suppose maximum operation. So when these two are put into this operation, we get this. Okay, these are by default basics, and again putting these two in operation, we get this. These two we get this. These two we get this. So now, basically, this is having a range of 4 only. Okay, just one element in the range. Same for this, for this, for this, for this. Now as we move up, okay, one more thing to notice is every leaf node is basically the part of this array, okay? Now this is basically having a range, this is having a range, this is having a range, this, and this is having a range, this. Now, how it will help me to find the maximum in this range? Let's perform this here. So what I'll do, I'll start from here, and 1 to 4 lie completely inside, so I will take the children of this. So this is having some part and this also having some part. So again look for their children. Now this 0 to 1 again having some part. So I'll look for its children. Now this does not exist, so I'll not take this. This exists, so I'll take this. Now its first child is explored. Second child exists, exists. Okay. Now that's totally fine. So basically what I did, I made this tree and performed the operation of selection in range. If the range I'm looking for is inside a node, then I look for its children. If that's out of the range I'm looking for, then I'll just leave it. If this is having a node completely inside, so I'll just take it completely. Okay. So if I'll take the range of node as Rn and range of query as Rq, okay? So first case is Rn is inside take complete, okay? Second case is Rn is out of this. So Rn, then don't take it, okay? Third thing is RQ is inside the Rn. RQ is inside, then look for children, okay? Obviously when RQ will be equal to Rn, then I'll take that whole. So if Rn is inside or equal to RQ, then take complete. If that's out of, don't take. And if that's inside Rn, so look for its children, okay? So the first thing comes, how will I implement that tree? So I implement that tree in an array. Now the question comes up, what will be the size of this array? Okay, so this will be my node in tree, and in this way my tree will be here, okay? I also know that the leaf nodes of this tree will be the elements of this array, okay? So I can say that the number of nodes in last will be n, and by looking this, like 1 is the number of nodes at this level, 2 at this level, so I can say that it will be like this is the number of nodes in my tree, okay? And now by geometric progression I can say that this will be equal to this. So this will be the number of nodes in my tree. Now I know that 2n is the number of nodes that are at last. So leaf nodes are this. But I also know that this is equal to n, the number of elements in this array. So I can replace this with n, okay? So total nodes, so this, now I understand that this is the complexity. Okay, this is obvious that in segment tree, every node will hold only 2 children, okay? Not more than that. So basically this is the tree for this. Now to store this in an array, so this is my segment tree array. First level over. Second level, secondly, 30, 56, over. Third level, over. Fourth level. Now this way I'll store the segment tree in an array, okay? Now, so basically there are 5 nodes, so 2 into 5 minus 1, that's 9. So 9 is the size of this array, that's totally fine. And now I'll start with the position given to me, okay? And the range given to me, that will be stored in this position. Because this is storing the complete array, so I'll be given with position and 0 and 8 to fill this. Because it's not just one element, so I'll not do it directly. I'll ask for its children to be made, okay? Now, if I is parent, then it will have 2 children, 2n plus 1 and 2n plus 2. If I start from 0, if I would be starting from first index, then its first child would be having the index 2n and second child would be having the index 2n plus 1, okay? But in general the array starts from 0. Now when I will be making this array, I will be given with 4 things. The array from which I will start making this, the position at which I am to fill the root node, okay? And the first index and the last index. Okay, these 4 parameters will be given to me to make this array, okay? Now, so I will be given with this array and position equals to 0 and first 0 and last 0, 1, 2, 3, 4. Now I am given with these parameters, this array, and in this blank array with, and this is my blank array. So what it will do, at this position I will store the range from 0 to 4. Now basically it will store the maximum of its children. So I will firstly fill the children of this node. So for first child that has index 1 and range 0 to 2. Okay. So it will again look for its first child, the index 3 and range 0 to 1. Now this will again look for its first child, so 3 into 2 plus 1, 7, so 4, 5, 6, 7. Here will be the first child of this. So it will have 7 index and just 0 element, okay? No range is there. So I'll simply take this from here to here, okay? Now its first child is here and its second child will be here. By the simple 3 into 2 plus 2, 8. So at this index, what I'll have the range this, and range will be just 1 only. So 10 will be stored here. Now we are done with this child. So it will store the maximum of its children. So this and this 10 is here, okay? Now for this range, its first child was having range 0 to 1, that's here, and its second child will have range 2 only. So because its second child will be at position 2 into 1 plus 2, that's this, and will have range this only. So it will store this only. Now this will store the maximum of its children. So this or this. For this I needed 2 children. First child is here. Now moving to second child. Now we are done with its second child as well. So this will store the maximum of its first and second child, that's 56 only. So I can say while filling I'll get these parameters, and if first is equal to last, then okay, let's name this as segment tree. Okay, it's 3. Okay, so if f is equals to L, then in this array at this position or index, fill A R, fill AR F. Okay, simple. So when this is equals to this, just fill this and return. Okay, but if it is having a range and first is not equals to last, then this means else I'll make 3 position of first child is here. Okay, for second child I'll do this again, 1 plus this, and last will be as it is, and done. Now this will make these 2 trees. Okay, and then I'll store the maximum of these 2 here. So maximum of its second child, So this is actual function we are using for making this segment tree array. Okay, now, so firstly I'll make the integer array, that segment tree, with a great size. Okay, now the void is the written type of this function. The function is make segment tree, makes tree. Now, after completing this make segment tree, I'll write a function that puts query. Okay, and if someone asks me that find the maximum number in this range, so it will return an integer. Okay, and it will take 5 parameters. It won't take this array, and this array is globally declared, so you have to take this obviously. And now I'll take the position, first, last, and for range I'll take from and to. And now these three cases are here. Okay, so if my from to, this is my actual range of query. If this is having this inside, so if from is less than first, so this means range of query is having this range of node completely inside. So in this case I'll return simple. Second case says that range of query is totally different from range of node. So if from is greater than the last, so from is greater than the last, this means my range of query is ahead of range of node, or my range of query is before the range of node. So 2 will be less than first. 2 will be less than first. In this case, I am at this case, so I do not want it to take anything. So I'll return a very small number. Simple, okay? So in this case, else, what I am to do? I am to just look for children, okay? So I'll just return the maximum of first child, that's 2. This means take this entire query over the first child in this range. So this is first child, this is the position of first child, and this is the entire range of this query, okay? So either take this, okay, you can complete this by your own as well. So this is actual game by making tree in order of n and completing the query in order of log n, okay? Now, let's see the computer screen. So after understanding this entire sweet concept of segment tree, there is a twist. When I'll update any index in this array, it will affect my entire segment tree, and this will affect the complexity of any update because the entire segment tree is to be updated. So the updation will become from this order to this order. So I hope you got the basic idea of this segment tree, the advantages and the disadvantages, when to choose what. And the second thing is, I'll make more videos related to this, the update function and the square root decomposition thing, and how to use what and all this. So stay tuned, make sure to subscribe to the channel, hit the like button if you like this video, and now see you next time.